Now we're going to be looking for the measurements of location. Now, this central tendency data is something that you guys have seen before. You guys are familiar. I remember in the first unit when I would come and ask, what's the population? What's the sample? What's the statistics? Many of you answered, oh, statistics are the mean, statistics are the mode, statistics are this or that. Now, that's actually the measurements of location. So you have a very good idea of measurements of location. You guys are familiar with some of these numbers. The mean, I'm actually for the mean, you guys know it also is an average, the word average. Now, a word that we tend to use a lot in statistics, sometimes we call it mean, sometimes we call it average, but the word that we tend to use a lot is arithmetic mean. Arithmetic mean. Okay, now that's basically the mean or the average. It's just that we used a fancy word. But we're also going to be using some Greek letters. Notice out here that I wrote mean, and then I wrote an X with the line on top. We're going to be using an X with the line on top, and then we're going to be using this Greek letter that it's called mu. Okay. So when we talk about mean, we're going to start using Greek letters. Now, this X with the little cross on top is basically the mean of a sample. So I have some data and I have sample. I have a sample there, and I can figure out what's the mean of the sample, right? I collected some information, not from the whole population. Remember back on unit one, we talk about population, what we talk about sample. So I didn't collect the data of the whole population. I just collected data of the sample. Now, sometimes we even label it. We might say the data, and I don't know, what if I write uh, S here? So probably I'm talking about data of some information about soccer, right? And what if I'm talking about the values of salaries in soccer, and I want to compare with the salaries of football? So am I gonna say, you see how they look about the same, but now the little subscript, the little letter at the bottom on the right, it's telling me the data of football, the data of soccer. We're gonna be playing with a little bit of that in your homework, okay? So this X thing with the little top, with a little line on the top, that means of a sample. And I even use a little subscript to talk about what sample am I referring to. Again, I could be comparing two different samples. Now, the Greek letter mu, it's pronounced mu, even though it looks like a U, it's pronounced mu. Now, that one we usually use it as the mean of the population. So it's of everything. Again, it could have some subscript because I'm talking about the population of soccer, population of football, population of basketball, right? I could be comparing different things. Now, the mean or the average is basically the value in the center. The way we're gonna find out what's the value of the center, we're gonna add all of the values. So if I'm looking at the sample, if I'm looking at sample, I'm gonna add all the values. So add all, I'm just gonna write add all. I'm gonna add all the data, all the values, and whatever I would get, I'm gonna divide this by the number of values. Just let me say it, numbered of values. For example, let's say I had a class of 40 students, and I ask everybody, okay, I want to compare it. I want to get the mean of you guys' GPA. So I ask all of my 40 students what their GPA are. I'm gonna get different numbers. I can get like 3.5, 4.0, 3.7. I'm gonna get different numbers, and I'm gonna add them all. I'm just gonna add them all. But then I'm gonna divide it by 40 because remember I said I had 40 students. So the mean, you add them all and then you divide it by how many values you had. Just be careful. Be careful. Am I asking about the mean of a sample? Am I asking the mean of a population? And again, I could use subscripts to be able to tell you which sample am I referring to. Because I could have different samples. but the little subscript is telling you which is the sample. Now, the median is the number that it comes in the center. It's a number that separates the order data. So order data means basically having from small to large. It separates it into halves. Okay, so half of the values are the same number or smaller than the median, and half of the values are the same number or larger than the median. So the median sounds like middle. The median, one thing I want to say about median is that the median may or may not be part of the data. So what do I mean with that? Let's say I had 5 numbers. I don't know, I'm comparing something, but my data, I have 5 numbers, and I'm going to put them from small to large. So let's say I have 3, 3, 5, 7, and 9. Okay, the number in the middle, that's my median. In this case, my median is part of my data. That number in the middle, that's the median. But let's say I actually had 6 numbers. Let's say my numbers are like 1, 1, 5, 7, 8, and 9. Okay, so here, let me draw a line right in the center, right? There's 6 numbers, so the center will be like right here. There's 3 numbers on the left, there's 3 numbers on the right. Notice how my data now, my mean, is not part of the data. So remember I said median may be part of the data or may not be part of the data. Now that line, I have my median is, what number does that represent? Notice how the line is in between 5 and 7. So I'm going to ask myself, what number is in between 5 and 7? Right in between 5 and 7. If I cannot figure it out, probably you guys see it as like, oh, I know, Mr. Leonzo, I know what number it is between 5 and 7. But in case you cannot see it, what we're going to be doing, we're going to do that mean of those 2 numbers, right? I'm looking at my median is in between 5 and 7. So if you don't know which number it is right in between 5 and 7, do the mean of those 2 numbers. So what do I mean with mean? Add them up. So 5 plus 7, and then divided by 2, right? There's 2 numbers. So 5 plus 7 divided by 2 gives me 6. Yeah, 6 is the number right between 5 and 7. Sometimes you can tell which one is the median when you have 2 numbers. Sometimes you cannot tell. Now mode sounds like more. Well, mode is the value that appears more than any other value in the data. Now you guys are familiar with this information. Mode, it sounds like more. Which data do you see more than anything else? Now sometimes my mode is just one number. Sometimes my mode is it's more than one number. For example, let's say I had a data, and let's say my data is like 3, 3, 5, 6, 8, and 9. Which number do you see more than anything else? Well, 3. In this case, my mode will be 3. Now, so my answer, if I was asking here, what's the mode? Well, just 3. Simple. Now, looking at another data, let's say I had something like 1, 1, 1, 5, 8, 9, 9, 9, and then a 10. Which number do you see more than anything else? Well, there's 2. I see 1 and 9. There's 2. So I'm just gonna go 1, comma, 9. I'm gonna list them both. Because they're the numbers, 1 and 9 are the numbers that I see the most, right? 3 times each. This is actually what we call bimodal. There's 2 modes. Now, can I have only 2 modes or only 1 mode? No. I could have 3 modes, I could have 4 modes, I could have as many modes as the data gives me. Mode is a number that you see more than anything else. Now, quartiles, we're going to move into Q1, Q3. We're going to call those quartile 1, quartile 3. Now, quartiles are the numbers that separate the data into quarters. So it sounds like quartile, sounds like a quarter. Now, quartiles may or may not be part of the data, kind of like median. It could be part of the data, it could not be part of the data. So quartiles may or may not be part of the data. Now, first quartile, quartile 1, is going to be the median of the lower half of the data. Huh, interesting. Median was what separated my data into two halves. Remember, two halves. There's a lower half and then there's an upper half. And I'm calling it lower and upper half because my numbers were listed in order from small to large. So my median separated a lower half and an upper half. Now, quartile 1 is the median of the lower half of the data. Okay, so quarter 1. Now, quarter 3 or Q3, the third quartile, is the median of the upper half of the data. Interesting. So what I'm saying is, let's say I had a list of numbers. Boom, boom. Let's just say I had a list of numbers. I'm not gonna really specify which numbers, but I had a list of numbers. And then I look in the centered. I'm like, oh, that's the median. I found my median. Now the lower half, I'm gonna say that's my quartile 1. If you notice, is the median of my lower half. Notice on my median, because I had 9 numbers, the median was actually a value on the data. Now, my lower half, there's 4 numbers only, so quartile 1 is not part of the data. Quartile 3, I'm looking at to the right of my median, so I'm just looking at the upper half. This will be quartile 3. Now, for those of you that watch sports, it sounds like quarter 1, mid or half, halftime, and quarter 3. My quartiles, look, it's separating my data into 4 sections. There is 1 section, 2 sections, 3 sections, and 4. It's separated into 4 sections. That's why we call it quartiles. The median separated into 2 sections, but the quartiles end up breaking it into 4 different sections, using the median still, though, using the median. Now, the interquartile range, sometimes we're going to abbreviate that as IQR. Interquartile range is the range of the middle 50% of the data. Middle 50%. The IQR, interquartile range, is found by subtracting the first quartile from the third quartile. So my data is broken down into 4 sections. I want to know what's the middle half. So I want to know middle half. That's going to be my interquartile range. What are the value? How big is my interquartile range? Now, what I'm going to do, I'm going to go quarter 3 minus quarter 1. So my interquartile range is found by subtracting the first quartile from the third quartile. So remember, I'm going quarter 3 minus quarter 1. The value that I get is how big is my interquartile range. Now, interquartile range is going to be very, very interesting now because we're going to have some outliers. Now, outlier is an observation, it's a data that does not fit the rest of the data, right? It's a number that is way, way off. Imagine I came over and I asked you guys, all right, guys, I want to see how much money do each of you guys have in your pockets? Boom, boom. So I look, I'm assuming you guys will have about the same data. However, we have this one student that is an athlete. Let's just say whatever sport you like. I don't know, soccer, football, whatever sport you like. But one of them is an athlete. Now, do you think that that player, or this person that works and gets paid a lot, you think that person is gonna have more money in your pocket or more money in their pocket than you? Probably more money in their pocket than even me, right? Like than any of us. So if I ask you guys, how much money do each of you guys have in your pockets? You guys should be about the same. Now, outlier is someone that is way, way off. Someone that throws our data off. That's an outlier. So it's a data, it's an observation that does not fit the rest of the data, right? That person is It's way different. That's why we call it outlier. Now, our non-outlier interval, so the values that we can use, our non-outlier interval is going to be, I'm going to say two, well, oops, let me use brackets. Now, interval, you guys are going to find out the interval are basically the values that I can accept. So non-outlier interval, I'm going to say the lowest number I can accept on the data without being an outlier. The lowest number I'm going to accept on my data is going to be quarter one, so quartile one, minus 1.5 times my interquartile range. So that's why the interquartile range is very important. The lowest number I can find on my, I can accept on my data is quarter one minus 1.5 times interquartile range. That's the lowest number I'm going to accept in my data. Let me put a comma. The biggest number I'm going to accept on my data without being an outlier is going to be quarter three. So quartile 3 plus 1.5 times the interquartile range. So my interquartile range is going to be very important. Let's take a look at an example of all these values that we use. So I might give you guys some information. I might give you guys a list of numbers, or I can give you guys a dot plot. Now this dot plot, you see how in the 49 there's 3 dots? So that means I have 49 3 times. So 49, 49, 49. I see 50 3 times. So 50, 50, 50. 51, I have it only once. 52, I have it twice. I don't have a 53, but I do have a 54. So I can look at my data as a list of numbers. I can have it as a dot plot. In reality, I need it as a list of numbers. And I'm going to list them in order from small to large. Dot plots are really good because it helps me look at it from small to large. I might give you a list of data. So I might give you a list of numbers, not in order. So you have to rearrange it. So what I'm going to do for the mean, because the first thing it says, it says find the following. First thing I'm going to do is find the mean. So I'm going to grab my calculator. I'm going to grab my calculator and I'm going to add them all. Don't want to waste your time. I added it before. So if I add all, I'm going to get 506. You don't trust me? You can add it yourself. So I added all my numbers. I'm going to get 506. Whatever I get, I'm going to divide this. I'm going to write it as a fraction. I'm going to divide it by how many numbers there are. It's easy to count the dots, or you can count how many numbers we have. There's 10 of them. So I'm going to go 506 divided by 10. In my case, it happens to be 50.6. My mean is 50.6. What does the mean really mean? Right? If I made all my numbers the same, so from the big numbers, let me take some values out and let me give it to the little numbers. So I take from the big numbers and I give it to the little numbers. One way that I explain sometimes mean is, imagine we all met in person. We all met in a group. And I said, all right, guys, I want us all to have the same amount of money. So what we're going to do is all of us are going to empty our pockets. We're going to take our money out. We're going to add how much money we have. And then we're going to divide it by how many of us are. So you add them all and divide it by how many. Okay, now median. I'm going to find my median. There, I'm going to say, okay, I'm going to draw a line that it's separated in the middle. There's 10 numbers, right? So what's the half of 10? 5. Okay, so I'm going to do a list. I'm going to draw a line that, let me draw this line right here. Notice how there's 5 numbers to the left of my line and there's 5 numbers to the right of my line. I need to have the same amount of numbers to the left of the line and then to the right of the line. Now, because I did not cross a number, my median is not part of the data. If I had crossed a number, my median will be part of the data. I need to have the same amount of numbers to the left than to the right of my line, of my segment here. Now, because my segment did not cross a number, so it's not part of the data, I look at the two middle numbers, 50 and 50. I can ask myself, what's in between 50 and 50, right? It's the same number, so I'm just going to say 50. Right between 50 and 50, well, it's 50. Now, what if I couldn't tell? I would have added my two numbers, 50 plus 50, and divided by 2. Okay, so my median is 50. Now, mode. I see 49 3 times. I see 50 3 times. And then everything else just once or twice. Okay, so I see two numbers tied for mode. Okay, so let me take a look here. My mode will be 49 or 50. I'm gonna type in with a space after the comma. So whenever you type this in with the space after the comma, does it have to go in order? Do I have to go 49 and then 50? Or could I say 50 and 49? It does not matter. Just make sure you put a comma between them and then you put a space after the comma. Now my quartile 1 and my quartile 3. Let me remind you of my data. I'm gonna write my data here. I had 49 3 times, 49, 49, 49. I had 53 times, 50, 50, 50. Then I had a 51, 52, 52, and a 54. I'm gonna write my data here. And then I remember I had a median. The median, I separated into 5 numbers on each side. So that line represents my median. Now my quartile 1. My quartile 1, I look at my numbers on the left. I gotta find the centered. Now I'm gonna say the centered is actually this number. It is an actual number. Notice how I'm just looking at the lower half. There's 2 numbers to the left of it, and there's 2 numbers to the right of it. So 49 happens to be a number. So 49 will be my quartile 1. For my quartile 3, I look at my upper half. I'm looking at there. What number is in the center? Well, it happens to be a data. There has to be a number from the data. So I'm going to call my quartile 3 is going to be 52. Now, my interquartile range, what I'm going to do, I'm going to go quarter 3 minus quarter 1. 52 minus 49. Now, 52 minus 49 is 3. Okay, so my interquartile range is 3. Now, for my non-outlier interval, one thing I want to do is I want to find out what is 1.5 times my interquartile range. Okay, that's a multiplication that I need to know. What's 1.5 times 3? Right, always 1.5 times interquartile range. In this case, 1.5 times my interquartile range happens to be 4.5. Okay, now why do I need that? For my noun interval range. My noun outlier interval, I mean, my non-outlier interval. Okay, so what I'm going to do, my lowest value that I can accept for my data is going to be 49 minus 4.5. Quartile 1 minus 4.5. So the lowest value that I can accept is 44.5. Now, what's the biggest value? It's going to be quartile 3 plus 4.5. So 52 plus 4.5 is going to give me 56.5. Sometimes my noun outlier interval might have decimals, and it is okay. We can deal with decimals. Now, if there's a number less than 44.5, I don't accept it. It's an outlier. It's a number that is not similar to my data. If there was a number bigger than 56.5, I don't accept it. It's an outlier. It has nothing to do with my data. Now here my data, there's every number is within the interval. So every number, it is accepted. I'm gonna accept every number in my data.